Hi everyone, welcome back. Today we are solving binary watch. So in this problem, we will be given a binary watch. It will have 4 LED on the top, so it will represent the hours from 0 to 11, and the 6 LED will be on bottom, and it will represent the minutes of the hour, which can be a number from 0 to 59. And we know since it's a binary watch, each LED will represent a 0 or 1. So for example, this will be 451, 4, and then this number will add up to 51. Now we will be given an integer turn on, which will represent the number of LEDs that is turned on in the binary watch, and we want to return all the possible times that the watch could represent with that number of LEDs turned on, and we can return them in any orders. So in this example, when one of the LEDs is on, we see that these times all match that, and when we want the watch to have 9 lights turned on, there are no ways to make that happen, so we return an empty array. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we should know that the number of LEDs on will be the number of ones in the binary representation. So for example, this is 451. The 4 will look something like this, so only one of the LEDs on, and 51 will have a binary representation like this, so it will have 4 lights on because there are 4 ones. So now that we know that, how we can solve the problem is we can first initialize result array to an empty array, and now we will iterate 12 times for the hours, and for each hour we will have to iterate 60 times for all the minutes within each hour. And now for all these times, we will find the binary representation of the hour and the minute, and then we will add up the number of ones and check if the count of the ones added up is equal to the turn on input variable that we are looking for. And if it does add up to be equal to turn on, then we will add the time to the resulting array, and finally, after iterating through all the times, we can return the result. So let's go through this example real quick. So obviously it will take way too long if we were to go through every hour and every minute, so I will just go through all the times where the binary representations matches one number of 1. So the first one will be at 1 minute, and then at 2 minutes, and then at 4 minutes, 8 minutes, 16, and 32. And then now it will be at the first hour flat, second hour flat, 4 hours flat, and 8 hours flat. And these will be all of them, so we can return this as our result. Now the time complexity would be O of 1, because no matter what the input is, we will have to iterate through 12 hours and 60 minutes, so it will be constant. And the space complexity is also constant because the size of these variables do not depend on the input, and this is what we are returning, so it will not count as space, so it's also constant. So now let's get to the coding part. So first we will initialize result to an empty array, and now we will loop through the 12 hours, and within each hour we'll check all the minutes. So for m in range of 60, and now we will do binary of h and count the number of ones plus the binary representation of m, which is the minute, and we will also count the number of ones, add them up, and see if they are equal to turn on. If it is, then we will add the time to result, and to make it in the format, we will use f string, so it will be h colon, and then we want to make sure that m is 2 digits with the 0 in front if it's a singular minute, so we will format it that way. And yeah, finally we can return result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.